Hello guys, welcome back to Statistical Academy. This is a continuation video of previous video. I have mentioned the link of previous video in the description. If in case you did not watch that video, you can watch it. Also, I am giving the links of example files. You can download and practice on them. In this video, we will work on accessing data values separated by blanks, missing values, accessing data values separated by commas, file name statement, which is an alternative method to specify an external file, accessing data separated by other delimiters, writing data lines in a program, the data line statement, the INFILE statement options with the data line statement, column input method, formatted input method, INFORMAT and FORMAT statements, syntax errors and resolving. As we have already seen one example of reading data values separated by blanks in the previous video, we will look at one more. List input is one of the easiest methods of reading data. By default, SAS assumes that data values are separated by one or more blanks. Now we have a text file called vitals. These values represent gender, height in inches, weight in pounds, systolic blood pressure, diastolic blood pressure. Each data value is separated from the next one by one or more blanks. We will write a program to access this file and create a dataset. You may have experienced a different sign-in interface that SAS has updated. Please click on sign in and use your credentials. Once you log in, please click on this launch icon to access the SAS Studio. Okay, now once you download your practice file using the link from this video, you should upload it to any of your folder of SAS Studio. We will use the path of that uploaded file to copy and paste inside the codes of INFILE statement. Let us run this program and see. Here is the output of dataset, which has gender, height, weight, sysbp, dibp variables. Let us look at the log. 7 records were read from the file. The dataset work.vitals has 7 observations and 5 variables. Now we will have a look at the program. The INFILE statement tells SAS where to find the data. The input statement contains the variable names we want to associate with each data value. The order of these names matches the order of the values in the file. The $sign following the gender tells SAS that gender is a character variable. What would happen if you did not have a value for the height for the second patient in your file? Your data file would look like this, a missing value in the line 2. Please try reading example file named missing_value, link mentioned in the description. It should be obvious that this will cause truncation, and instead of 7 observations, we will get 6 observations. SAS reads the value 156 for the height and 110 for the weight and 75 for the sysbp. dibp will be missing. Because there are no more values on the second line of data, SAS goes to the next line and attempts to read the 156 as a height value. Clearly, you need a way to tell SAS that there is a missing value for the height in the second line. One way to do this is to use a period to represent the missing value. Like this in your file, I have created one more file, missing value _ period. Link for this file also can be found in the description. You must separate the period from the values around it by one or more spaces because a space is the default delimiter character. SAS now assigns a missing value for the height for the second patient. You can use a period to represent a missing character or a numeric value when you use list input method. A common way to store data on Windows platforms is in comma-separated values, CSV files. They may or may not enclose character values in quotes. The file class.csv contains values representing gender, age, height, and weight. Values are separated by commas and character value gender is enclosed in quotes as shown here. We will write a program to read this file and create a dataset. A program to read data from a CSV file. Class is the dataset name. INFILE statement, I have already copied the location of uploaded CSV file. So I'm pasting it here. Input statement with variable names. With a minor change to the INFILE statement, that is DSD. Okay, now let us run this program. Yes, program ran just fine and we have imported file successfully. All the 17 records were read from the file and we have 17 observations and 4 variables in the dataset. Now we will have a look at the program. Notice the INFILE statement in this example. The DSD, delimiter sensitive data, following the file name is an INFILE option. It performs several functions. First, it changes the default delimiter from a blank to a comma. Next, if there are two delimiters in a row, it assumes there is a missing value in between. Finally, if character values are placed in quotes, single or double quotes, the quotes are stripped from the value. I will be using same class.csv file to demonstrate an alternative method to specify an external file. I will run this program and see. Program ran fine. 17 records were read from the file Mihika. And we have 17 observations and 4 variables in the dataset. Let us have a high-level look at the program. The INFILE statement in the first program used the actual file name placed in quotes to specify your raw data file. And second program shown here is an alternative method to use a separate file name statement to identify the file and use this reference called a file ref in your INFILE statement instead of the actual file name. Both first and second programs are identical except for the way it references the external file. The name following the file name statement, Mihika in this example, is an alias for the actual file name. Notice also that the file ref in the INFILE statement is not placed in the quotes. This is how SAS knows that Mihika is not the name of a file but rather a reference to it. Remember that the default data delimiter for list input is blank. Using the INFILE option DSD changes the default to a comma. What if you have a file with other delimiters such as tabs or colons or any other special characters? For example, we have a text file called other DLM data. Data in that file is like as shown here, separated by asterisk. No worries, we have another INFILE option called DLM. You only need to add the DLM option to the INFILE statement. We will write the program and see. We have successfully created a dataset from the text file with values separated by the special character asterisk, 6 observations and 5 variables. Now let us look at the program. To read these kinds of files, you could use this INFILE statement option DLM equal to. You can spell out the name of the delimiter option instead of using the abbreviation DLM if you like. Here is the task for you. Please prepare yourself a text file with as many special characters as you like in single file, and you can use DLM option to specify all of them in the quotes like as shown here. Please comment if you get any doubts on this. Suppose you wanted to write a short test program in SAS. Instead of having to place your data in an external file, you can place your lines of data directly in your SAS program by using a Datalines statement. For example, if you wanted to read data from the text file vitals.text, blank delimiter data with values for gender, height, weight, systolic blood pressure, diastolic blood pressure. But you don't want to go to the trouble of writing the external file. We will write the program and run. I'm going to run this program. Dataset successfully created and it has 7 observations and 5 variables. Let us look at the program now. As you can see from this example, the INFILE statement was removed and a Datalines statement was added. Following data lines are your lines of data. You may either use a single semicolon or a run statement to end the data step. The lines of data must be the last element in the data step. Any other statements must come before the lines of data. You would probably not use data lines in real time. It is extremely useful when you wanted to write the short test programs. By the way, you can also write cards instead of data lines. Both are same. What if you use data lines and wanted to use one or more of the INFILE options such as DLM or DSD? Let us run this program and check. Okay, we have created the data set and it has 7 observations and 5 variables. We will go back to the program and check. You can use many of the INFILE options with the data lines by using a reserved file reference called Datalines as shown here. Instead of an external file in the INFILE statement, we are writing data lines. Please try the same with other delimiters and use DLM option. Before going further into this column input method, let us have a look at the data in the text file hospital. The file has patient ID, date of admission, gender, systolic blood pressure, diastolic blood pressure, and medicine cost. Patient ID is starting from the position of 1 and through 4 in the text file. Date of admission is starting from the position of 5 through 14. Gender is at the position of 15. Value of systolic blood pressure is starting from the position of 17 through 19. Diastolic blood pressure is starting from 21 and 22. Medicine cost starting from 24. Now we will go for the program and run it. We have successfully created dataset from the text file. We will have a glance at each line of the program. The simplest method for reading data in fixed columns is called column input. This method of input can read character data and standard numeric values. And as we know, we can write multiple statements in single line and single statement can be written in multiple lines. Here I have written input statement in multiple lines. The patient ID value spread across from the position of 1 to 4 in the file. So we must mention the position. The same way for remaining variables. Date of admission, gender, systolic blood pressure, diastolic blood pressure, medicine cost. So please prepare more files and practice on them. It would be so interesting. Let us now work on the same hospital file, but this time formatted input method. I'm going to submit the program. Dataset has been created successfully with 4 observations and 6 variables. Now we are going to have a high-level look at the program and as well as the output dataset. Data for both methods is same. So first thing, the @ symbol, @ in the input statement are called column pointers. It will point the starting point of the data. For example, our data values for patient ID are starting from the position number of 1 in the text file. Same way for the remaining variables. Date of admission at position 5, gender at 15, systolic blood pressure at 17, diastolic blood pressure at 21, medicine cost at 24. Following the variable names are SAS informats. Informats are built-in instructions that tell SAS how to read a data value. The choice of which informats to use is dictated by the data. Here, two of the most basic informats are w.d and $w. The w.d informat reads standard numeric values. The w tells SAS how many columns to read. For example, SysBP is spread across the length of 3. So we have given 3 dot informat. The optional D tells SAS that there is an implied decimal point in the value. The $w.INFORMAT tells SAS to read W columns of character data. In this program, patient ID is read as character data and takes up 4 columns. Values of gender take up a single column. And now it's time to read the date. The DDMMYY10.INFORMAT tells SAS that the date you are reading is in the DDMMYYYY form. SAS reads the date and converts the value into a SAS date. SAS stores dates as a numeric values equal to the number of days from January 1st, 1960. Let us use this simple program to understand this. I am running a sample program with 3 dates. It ran fine, and now we will look at the program and the output dataset. If you read the value of 1st January 1960 with the format of DDMMYY10. SAS stores a value of 0. If you read the value of 31st December 1959 with the DDMMYY10.INFORMAT, SAS stores a value of -1. The same way for our hospital dataset. Dates are stored as number of days from the 1st January 1960. Using INFORMATs and FORMAT statements. I'm going to place the data lines in the program with the data line statement using list input method. This is the employee data. Data values are date of joining, name, employee ID, salary in British pounds. Now we need to supply INFORMATs to tell SAS how to read a data value. As date of joining is in MMDDYYYY format, we need to supply MMDDYY10.INFORMAT. Name length is greater than 8 bytes, so we need to supply INFORMAT to accommodate the maximum length of string. We will give $20. For employee ID, we will give $6. As salary included with the GBP sign, we need to supply NL-MNL-GBP.INFORMAT. Now, let us run the program. Program is executed successfully and dataset has been created with 4 observations and 4 variables. As you can see, date values are stored as days and all variables are read perfectly fine. Now we will apply some formats on these. Formats are used to specify how data values are displayed. In this example, the format statement is used in the data step to display the DOJ variable in the date9 format as a 2-digit day, 3-letter month and 4-digit year. Also, NL-MNL GBP to display the data with the British pound. We can also use $format and many more. Remember, when you use a format, the format name contains one period at the end. We will be learning so many INFORMATs and formats throughout the course. Syntax errors are fact of programming life. As a programmer, it's incredibly valuable to be able to identify, diagnose, and fix syntax errors in your code. Examples of syntax errors include misspelled keywords, unmatched quotation marks, missing semicolons, and invalid options. You can catch some syntax errors such as unmatched quotation marks by paying attention to the color-coded syntax. When SAS finds a syntax errors in your submitted program, a warning or error message is written in the log. Let's look at one program that contains some syntax errors. This program actually has 3 syntax errors, and the color coding within the editor window helps us to recognize where those problems are. For example, the first one is DAAT. Data is simply misspelled. You'll notice that other keywords are in a bold blue font where DAAT is not. I'm not going to fix the problem yet, but let's identify the other errors. Here is another one. At the end of proc print, we are missing a semicolon. Again, you will notice the difference in the coloring of the keyword that follows where and where. And finally, in the proc mean step, you'll notice that average is an option and it doesn't have the same blue coloring that the other options do have. So let's pretend we did not notice these syntax errors and run our program. It looks like some output data was created, But we should always look at the log, and this step should be a very first step all the times. Let's go to the top by scrolling. It's always critical that when you examine the log, you read it from the top to bottom. So the first thing we get is a warning. DAAT is underlined, and SAS tells us it assumed that data was simply misspelled. You'll notice that it goes ahead and successfully runs the data step. What about the next error? You'll notice the word where is underlined. Although we haven't discussed about specific syntax in procprint yet, the keyword where is valid. It shouldn't cause a problem. When you see something underlined in the log and the syntax for that item is accurate, then the best tip I can give you is to look immediately before what is underlined, because that's probably where the issue is. As a matter of fact, let's read the message. SAS says syntax error expecting one of the following, and notice the very first thing it suggests is a semicolon. The problem was indeed immediately before the keyword where, the missing semicolon at the end of procprint statement. Because the semicolon wasn't there, SAS assumed that where was simply a continuation of the procprint statement, and where is not a valid option. However, the message in the log does indicate what are other valid options would possibly be on the procprint statement, so we can fix that syntax error easily. Because of that error, you'll notice that SAS system did not process the step. In other words, the procprint did not run. Well, let us look at our last error. Again, average is underlined. The error message indicates what valid options we could use on the procmin statement. Average is not one of them. However, as an alternative, we can instead use mean. This step also did not run because of the errors. So now we have diagnosed all three syntax errors. We can return to the code tab and make the fixes. You will notice as I did make those corrections that the color coding of the program now looks much more consistent, and now I am ready to run my code again. And before looking at the results, I'll check the log and confirm there are only notes after each step. Learning to read the log and diagnose your syntax errors is a critical skill you will need to develop as a SAS programmer.